Well, welcome back. It's good to be back, and I'm just going to jump right into probably the most challenging chapter in the entire book. Not really challenging in the sense of understanding the concept, but more challenging because there's a lot of stuff to remember. But it's definitely good to be back in the swing of things here, and I'm going to just jump right in, and I look forward to seeing you guys Tuesday and Wednesday of next week. So hopefully this video finds you doing well and already understanding the concepts that you learned from the 9A and the 9B packets. And this officially is the 9C packet, so it's the beginning of it. And I don't know, since I haven't been there, if you guys learned a very important concept. So I'm going to reiterate what that concept is. And that's that f of x is equal to, so any function, or at least the functions that we'll be studying, can be represented using a power series or an infinite series. And the first thing we want to make sure is that you understand where all of the coefficients are coming from and where all the terms are coming from. So if I need to clarify this on Tuesday, Wednesday, then I will do that. But I'm going to go on the assumption that you know that f of x can be written as a polynomial in which the first term, and by the way, we're going to be centering this polynomial at 0. The other polynomial is centered at different values of x. I'll show you that later. So this particular polynomial is going to be centered at 0, and f of x can be written as f of 0 plus f prime of 0 multiplied by x plus the second derivative at 0 multiplied by x squared over 2 factorial plus, and we just keep going. Each successive derivative at 0 multiplied by x to that power over that power factorial, and then we keep going, plus dot dot dot, and it just keeps going. Okay, so that's approximating, or that's actually rewriting a function in terms of a polynomial function. As you can see, you have the constant term, the linear term here, the quadratic term, the cubic term, and so forth. You just keep going. And two of the questions that are kind of like the common thread through this entire unit is, what is the series, or what is the infinite series that represents that particular function, and then does the series converge? And if it does converge, what is the interval of convergence? So keep in mind that that's really what we're searching for. Does the series converge? And if it does, what does it converge to? Alright, well, that takes care of that little part, but if we want to take a polynomial, like what this says here for this particular problem, constructing a 4th degree polynomial, and keep in mind a 4th degree doesn't mean 4 terms. Could have 1 term, could just be x to the 4th. The largest power of x here can be 4, and that's a 4th degree polynomial. So again, it could have 4 terms, could have 5, could have fewer than that as well. So just make sure you keep that in mind. So we're constructing a 4th degree polynomial with the following behavior, and the behavior that is being referred to is this behavior right here, where we're given bits of information about the function. The polynomial at 0 is 1, the first derivative of the polynomial is 2, and so forth. So what I wrote up here is a function, f of x, but we want a polynomial function. So for a polynomial, f of x, we're going to approximate that using a 4th degree. So I'm going to use the capital P to represent a polynomial function, okay, which is equal to the polynomial at 0. So it's going to look really familiar, close to what you saw right up here above this. So that's P of 0 plus P prime at 0 multiplied by x plus P double prime at 0 multiplied by x squared over 2 factorial. I'm going to scoot on over here so you can see everything. Plus the third derivative at 0 multiplied by x to the 3rd over 3 factorial plus the 4th derivative. And once you get past 3, you usually put just in parentheses 4th derivative at 0 multiplied by x to the 4th over 4 factorial. Well, now it's pretty easy. We can see that p of x all we have to do is fill in the right numbers here. And let me just do this using red. Our p of 0, well, that's just 1. That's what was given. Okay. Our p prime at 0 is 2. P double prime at 0 is 3. Triple prime is 4. That makes it pretty easy. And the fourth derivative at 0 is 5. And so I'll just put that down there in the line just below. Okay. And let's scoot this over so you can see this part. And let's put this as P4. I like to have the 4 there because it reminds me right here. It reminds me that it's a 4th degree polynomial. Okay. And the 4th degree polynomial is 1 plus, and you see 2x plus 3x over 2 factorial plus 4x, did I mess up? Yeah, 3x squared over 2 factorial plus 4x cubed over 3 factorial plus 5x to the 4th over 4 factorial. Okay, and that's your polynomial. That's your 4th degree polynomial of x, polynomial of x, in terms of x, that approximates the function that has this behavior. Now we're going to get more specific as far as functions down here. You can see this ln of 1 plus x. So we'll get more specific about what functions we're approximating with polynomials. But if by chance you guys have not covered this part right here, just understand that this part right here, this is called a Taylor polynomial. And we're going to see that on the next page. It's called a Taylor series or Taylor polynomial, infinite series. You call it a lot of things, but Taylor, when we center it at 0, we will call it a Maclaurin series. So Maclaurin series is a Taylor series centered at 0. So that's why I said this chapter has a lot of vocabulary in it. I'll know better what you guys know and what you don't know when I get back. So if there's anything here that I've covered, you're like, oh my gosh, it's too complicated, I don't understand. Well, I'm assuming you have a bit of knowledge about these Taylor polynomials, or these Taylor series here, and using a polynomial to approximate a function. So don't sweat it if it's going a little bit over your head right now, but try to understand that this right here, this equation in which you take a function and you rewrite the function in terms of an infinite series, this is going to be your bread and butter right there. So I'll see you in the next video. Pick up from where we left off.